In this video, we'll discuss route preference values. A route preference value is a unique number that identifies the preference of a route, or think of it like a priority value on the knowledge of the route itself. So there's different ways that a router can learn of routes, and those different ways, there should be kind of priorities based off those different methods so that the route can choose, okay, I've learned this knowledge of this route, through, technique number one versus technique number two, which one should I use, right? So that's the idea of the preference values. Now let's take a look at a quick little example right off the bat. The example is if we have a router that has multiple network cards or interfaces in the router, and we connect those interfaces to networks, then what happens is the router learns of those networks instantly by being connected to those networks. And that type of knowledge should be very trustworthy, right? So the preference value for a directly connected network has a preference value of 0, right? And bottom line is the lowest preference value is the knowledge that the router will use. So let's say that I connected to a network through an Ethernet interface, and the network's got the network ID of 192.168, 3.0. So because I'm connected, the 3.0 network is going to have a preference value of 0. Now let's say as well, as a network administrator, I statically configure a route for the 192.168 3.0 network, right? So the router learns of the network automatically by being connected to it, but at the same time, I go in and I program the router for the 3.0 network, and maybe I give it a different routing entry. I tell it to send the data to a totally different place. So which entry will the router use? Again, it's all based off this preference value. So a directly connected network has a preference value of 0, but a statically configured route has a preference value of 5. So in this case, what happens is the router looks at those two different routes and says, okay, I know about the 192.168 3.0 network two different ways. Which route should I use? And it'll use the directly connected route, because it has the lowest preference value. So that's kind of what the purpose of these preference values are, is to give some sort of priority to the router when it goes through routing selection and chooses a route for a specific destination network. Now, these preference values also, I think they logically make sense. So it makes sense that a router would choose a directly connected route over something I program as an administrator, because I could program a route and put in some incorrect values, right? So it makes sense to go with what the router actually is physically connected to over what I tell it should be using. So that's why, in my mind, I'm thinking it makes sense that the preference value for directly connected is lower than a static route. Also, the router will have system routes, so it makes sense that the system routes have a lower preference value than, let's say, a static route. Again, something that the router is kind of programmed for itself, it should be used over what I program. But then what happens is we learn of routes through dynamic routing protocols. And these dynamic routing protocols are sharing routes, which is information coming from other routers that potentially have been programmed by other administrators. So I don't know if I really want to trust those routes or the knowledge of those routes over what I code as an administrator. So you'll notice that the other preference values, as I go through the next couple slides, I've got a huge chart here that shows different preference values used by different routing protocols. So a very common routing protocol is the OSPF routing protocol. So notice that if my router gets knowledge of a route through OSPF, it has a preference value of 10. And notice that my static routes would have a preference value of 5. So if my router learns of the 192.168 3.0 network through the OSPF protocol, and that conflicts with what I've coded the router to use, notice that my route would win because I have a lower preference value, right? So the static route has a lower preference value over the OSPF route. Now, also I want you to understand that OSPF is an example of a link state routing protocol versus, I'm going to flip my slide here, versus the RIP routing protocol. RIP is a distance vector routing protocol. Now, OSPF is aware of the links, so it is using link state, so it is bandwidth aware, link aware, availability aware, which is kind of a much smarter protocol, I would say, than something like an old RIP routing protocol, which is distance vector. Remember, distance vector only knows about hop counts, right? So how far the network is away. So notice that a route that's learned through the RIP routing protocol has a preference value of 100, right, compared to the value of 10, which was used by OSPF. So if I'm running both protocols and I get knowledge of the 3.0 network, through both RIP and OSPF, then the route for OSPF would be used, right? So because it has a lower preference value. Also notice that IP version 6 version of RIP is RIP-NG, and notice that it has, a default preference value of 100 as well. So that's the idea of these route preference values. So here's a couple more, again, highlighting just some of the common protocols. So is as a protocol, notice that for different levels of is, there's different preference values. And again, the lowest preference value is what would be selected by the router. So in this video, we discussed route preference values.